I'm Sehan Rathnayake from Data Platform Team, Sysco Labs.
Hi, I'm Sineth and I'm also from data platform team here at Sysco.
So can you guys tell me a little bit about what are the most common problems that organizations face in terms of leveraging their data when they scale?
Okay, if we look back few years and compare it with today, we can see that there is an exponential growth of the data that an organization can access. And this will be increased and it will exceeds the amount of the data that can be stored or computed in traditional database solutions. Handling this kind of huge data volume will be a really big problem when it comes to leveraging the data. And another problem will be the handle the real-time feed, because every seconds there will be thousands of documents which mean data are produced, as well as the current documents will be updated. Get these real-time data and the historical data in one view will be a real big problem. And another problem will be nowadays most all the organizations use microservice architecture, where this microservice architecture scattered their data across multiple database solutions, and provide analytics based on these diverse database technologies will be a really difficult task, since these databases are not designed to with the intention of catering these analytical needs, but they just fulfill the needs of their respective applications. These are the biggest problems when it comes to leveraging the data.
So what kind of considerations need to be taken into account when designing a solution?
Yeah, when you are designing a solution like this, one of the things that you must consider is the type of data that you deal with. Basically, we can split data into two categories. One can be structured data, and another can be unstructured data. Now, if you take structured data, example would be like the data that we find in a database. So there's a proper structure, there's a proper naming, and conventions are all there. So it's pretty easy for you to do searches or aggregations over structured data. But if you take unstructured data like images, photographs, or whatever, those unstructured data, it's not that intuitive or very trivial. So the approach that you're going to take when you have unstructured data and structured data would be entirely different. So if you're designing something like this, it's very important that you know what type of data you are dealing with, whether it's structured or unstructured, and based on that you must identify what your plan ahead going to be. Another one I would say is like the size of data. Now we are living in the information age, they say. So we are loading petabytes of data. So it's very important that your solution or the design that you're going with can handle these extraordinary sizes of data. So it might work for in a short period of time, but as the system grows and system continues to operate on production, it's very important that your systems can actually handle the data load that it's going to have. So it's another concern that anyone who's designing something like this needs to have, the size of the data. Another one I would say is like the processing power that's included in processing these data. So as I mentioned, with the size, if the processing power gets higher and higher beyond the economical benefits of developing something like this, so it's not going to be scaled out very good, and it's not going to be very practical at all. So it's very important that when designing something like this, again, you must take into consideration amount of computational power that you're going to put into this. So those are a few things that you must consider upfront when you're designing something like this.
So what approach would you recommend for building a solution that takes all of this into consideration, and why would you recommend that?
Okay, if we take any data processing architecture, there will be like 3 layers. Data layer over message queue, where we get the data, and then there will be a data processing layer where all the data transformation and data processing will happen, and there will be a data serving layer. But the problem is when the data volume increase, the data processing part will be very expensive, and to cater this huge data amount, we have to have very high throughput. So in the traditional approach, if we want to have a very high throughput, we have to live with very high latency also. But with the need of the real-time analysis increases, the organization need to know what's happening right now. So getting these data with low latency can't be done in traditional approach. That's where the Lambda architecture fits in. What it's try to do is it try to balance latency, throughput, and fault tolerance with huge data loads. What it does is it separates that data processing part into two layers, the speed layer and the batch layer. In the speed layer, what it does is it uses stream processing to give the view of the real-time data with very low latency. And in the batch layer, it will use batch processing. It will give comprehensive views of batch data with high throughput. In this way, it can give very high throughput with the low latency. That's about the Lambda.
Okay, so the unified data platform at Cake is built using and around this approach, right? So can you tell us a little bit about it?
Yeah, so the Cake data platform that we have developed is kind of a centralized ecosystem where anyone in Cake organization can pump their data into our data platform and they can perform analytical tasks on top of it. So that's one of the things that the Cake data platform itself does. It provides a centralized ecosystem for carrying out analytical tasks. Another one I would say is like the data platform itself can handle multiple data sources. Now, as an organization, as we grow, we are getting data from multiple data sources. It can be either POS machines, it could be mobile devices, IoT devices, whatever it is. So we are getting streams of data from several data sources. Now, if you are developing an application to handle all these data from diverse data sources, it's going to be a little bit complicated. But with unified data platform that we have developed here, it's pretty straightforward and really simple. So as an organization, we are getting multiple data sources into data platform as a single service. So that's really simplifies the workflows for us. And I would say another advantage that we have because of the Cake data platform is that we can leverage on the relational databases that we use in our organization. So we don't have to stress our databases to carry out the analytical task. So if we are to get a report or something, we don't have to stress our relational databases to pump out the data. So data platform takes care of all the analytical tasks. So the traditional transactional DBs, so MySQL or whatever it is, they can do what they are intended to do. They can do their transactional database queries and whatever, and they can be based at what they are intended to be based and not to do the analytical task, because data platform itself takes care of the analytical task. So those are few advantages that as an organization the Cake data platform provides to the organization.
Okay. So can you tell us at a very kind of high level how all of this has been put together?
Okay, if you think Cake data platform as a black box, there are two APIs through which the outside world can use data platform. One is integration API, which will be used to register your data stream and to pump data into the data platform. And the other one will be query API, which will be used to query the data from the data platform. And each data comes into a data platform through data integration API will go to a message queue, which will be act as to decouple our processing part from the data ingestion part. And after that, the processing will be started. To this processing to be happen, by the time you register data stream, you can provide multiple specification telling the data platform that the way the data should be pre-processed. The user can define one or many specification based on their reporting needs. These have very simple JSON format, so using these simple specifications, we can get rid of the need of writing ETLs for different data streams. When the data is being processed, it will be processed based on these specifications and will be saved in search optimized data store, which will be the real-time view of our data. And there is another, the aggregated data store, which has pre-aggregated historical data, which will be the output of our batch layer. And when a query comes to our data platform through query API, it will carry from these both real-time view and historical view. It will carry from both and consolidate the result to give the end result. And apart from this flow, there's another flow going on parallel to this. Every document come into our data platform will be saved in raw format also in a fault-tolerant, high available data store, which can be again used for running analytical tools and for archival purposes.
So, what issues within Cake does the UDP solve, and what benefits also does it provide?
One of the problems that UDP solves itself is like we don't have to have specialized teams, like one team specialized in generating reports or one never doing business analytics. You don't have to do that with the UDP. It's pretty straightforward to design and develop your applications on top of UDP. So anyone in the organization can simply pump data into UDP and query from it. So you don't need to have specialized team. You can just assign members to a team, and they can also continue their development task as well. So it simplifies the entire workflow and also decouples teams from each other. Like you don't have dependencies on top of each other. So it's pretty much straightforward answer to having specialized teams. And another advantage I would say is like we have what you call siloed databases, where there are so many systems running out there and they have their own databases, and it's not really simple to get data from those databases because you need to have some business insight or domain knowledge in order to understand what's going on these databases and get whatever you need. So it takes a little bit more complex mindset as well as a little bit more insight into the business logic to get data into whatever analytical task that you're going to carry out if you have siloed databases. Now that's a disadvantage because you need people with specialized knowledge on this. The data platform, since I mentioned you earlier and Sehan also, it's a unified it unifies all these data into one centralized place, ecosystem, where anyone can come and put their data and get data out of it. So if you take siloed data, this UDP solves or eliminates these siloed databases that we have in our organization. So anyone who wants to do analytical tasks that span across several systems, they can simply pump data into the UDP and then they can carry out analytical tasks. So that's pretty straightforward and a really good design perspective. Another one I would say, as well as Sehan mentioned, was that you don't have to write ETLs. Now traditionally ETLs were the go-to solution when we have to process data. Now that's complicated as well as it's very high on maintenance. So you need people who know the ETL very well, and you can't really go and swap members out of the teams as well. So without having to write ETLs, the unified data platform that we have designed takes care of all these ETL-based processing tasks and gives a black box kind of a thing to the user. So they only have to think about pumping data into the data platform and getting data out of it. So that's pretty straightforward, as well as we have query language, which is very simple, as well as anyone can learn from it. Like it's a very short learning curve. So the entire process of ETLs is eliminated from these things. So and the query API also performs very well with these query languages. So that's one of another advantage I would say. Another one would be as Sehan mentioned, the real-time and the historical data feeds. So there are times where you need to have real-time data as as you put data into it, you need to see the data. So that's one concern, as well as you need years worth of data for your maybe accounting task or whatever it is. So the data platform can cater both these at the same time without having a very high cost or the latency and having fault tolerances as well. So it's a really balanced solution, I would say, that gives us a huge advantage over the traditional processing models. Yeah.
Okay, so finally, can the data platform be scaled?
Yes, of course. If we take the API of the data platform, the ingestion API and query API, both are ECS deployments where it will get a scale based on the load. And if we take the message queues and the data stores we used in the platform, they all are cluster deployments where we can increase the capacity by simply adding new nodes to the cluster. And all the processings are done in distributed computing cluster, where if we need more processing power, we can simply just add new nodes to the cluster. And everything in data platform is scalable. So as solution, data platform is scalable.